In this video, let us see about the charge, current and the voltage terms used in electrical engineering. Whenever we talk about electrical engineering, the first thing come to our mind is electricity. So, in this video, we will see about the basics of electricity. Let us start with the structure of an atom. An atom consists of a central part, that is the nucleus, which consists of protons and neutrons. And in the outer orbit, you have the electrons. So at normal condition, an atom is said to be neutral. That is, number of protons is equal to number of electrons. And you can see two types of charge here. That is, a plus symbol is represented in protons and a negative symbol in electrons. It indicates that there are two types of charge, a positive charge and a negative charge. How to get a positive charge? If you take a neutral body which consists of equal number of positive charge and negative charge, if I want to get a positive charge, I have to remove some of the electrons from this neutral body, and then the resultant one will be deficit of electrons. That is, positive charges are greater than the negative charges, then this body is said to be positively charged. Similarly, to get a negative charge, I have to make this neutral body to have more electrons compared to the positive charge. So, if I add some more electrons to this one, the resultant body will become negatively charged. So, electrically neutral condition is where both the positive charges and negative charges are equal. And the other thing to be noted here is that always opposite charges attract each other and the same charges repel each other. So now how to measure the charge? So the charge of an electron is very small. So it is very difficult to measure this charge. Suppose for example, I want to buy a single strawberry or a single pepper. Can I measure it using a weighing machine? No, because the machine may not read that one. It is very small, so it is difficult to read. So similarly, since the charge of an electron is very small, what is done is you are measuring a number of electrons together. That is, instead of measuring a single electron, you are measuring the charge of 6.28 into 10 power 18 electrons. So the whole thing combined together, I call it as 1 coulomb. So coulomb is the unit of charge. So 1 coulomb is equal to charge on 6.28 into 10 power 18 electrons. So let me recall what we have studied. So there are two types of charges. Positive charge, it means that there is a deficit of electrons. Negative charge, it means that excess electrons are there. And the SI unit of charge is coulomb. And 1 coulomb is equal to 6.28 into 10 power 18 electrons. Next, let us see about electric current. Now, let me consider the bulb. If I want to make this bulb to glow, I have to connect it in the circuit and switch on the voltage supply. So, in that case, current will flow and the light will glow. Now, let us see how this happens. We all know the electrons have negative charge. Now, I am taking a copper strip which has a large number of free electrons. So, these free electrons will be moving in random direction. If I want to make the current to flow in this copper strip, I have to apply a potential across this strip. Now, we have applied the electric potential across the copper strip, and the electrons which are negatively charged will be attracted towards the positive terminal. And this directed flow of electrons is called the electric current. So the direction of the free electrons is actually the electric current. And this is similar to the bulb case, where if you connect the bulb in the circuit and switch on the supply, current flows. And you have to remember one thing, whenever you break the circuit or there is any opening, current will not flow. So it is necessary for the current to flow to have a closed path. So only when there is a closed path, electric current can flow. And another thing is, we have taken the electron direction as the electric current, but conventionally it is considered or it is assumed that the current always flows from the positive terminal. So the conventional current direction is just opposite to the electron direction. Now let us see about the unit of electric current. So you take the switches. So what type of switch it is? It's a 5 amp switch. It is used for small appliances. Normally we connect a fan, tube light, everything for this type of switch. And if you want to connect a heater or kettle, you will use a 15 amp switch. So what is the unit of electric current? This ampere is the unit of electric current. So it is named after the scientist who invented the Ampere's law. Now let us see the formula for electric current. So current is equal to rate of flow of electrons, or you can write charge flowing per second. So current I is equal to Q by T, where Q is the charge and the unit of charge is coulomb, and T is the time and the unit of time is seconds. So I is equal to Q by T. And you can write I, the unit of current we have seen, it is ampere. So 1 ampere is equal to 1 coulomb per second. So you take the circuit, a small circuit which is supplying a bulb, and you connect a ammeter. So this circuit is said to carry 1 amps. If at any cross section of this wire 1 coulomb of charge, that is 1 coulomb of charge, flows for 1 second, then we say 1 ampere of current flows in this circuit. Next, we will see about the voltage. So you see a wall clock, you use this type of cells for the wall clock to operate. So you can see here this voltage is 1.5 volts, and you might also seen this type of cells, a 9-volt battery for some toys applications, and this type of battery you might have seen in automobiles, or for some other application we can use it. So one thing you can note here is, even though these batteries are not connected to any circuit, they will give you a voltage. If you see the current, only when there is a closed path current can flow, but voltage will exist even when it is in open condition. So if the battery is not connected to anything also, you will get the voltage. So we will see what is that electric potential or voltage. So you take a circuit element, it can be anything, and it has 2 terminals. Now if I want to inject a current through this element, I have to do some work. That is, current is nothing but it is a flow of electrons. So flow of charges. So to move this charge from one point to the other, I have to do some work. That is called the voltage. So the voltage is the measure of the work required to move the charge through the element. So voltage is equal to work done divided by charge. So work done will be measured in joules and charge will be given in coulomb. So the SI unit of voltage is volt. And a body is said to have an electric potential of 1 volt if 1 joule of work is done in moving 1 coulomb of charge from one point to the other. So you are moving a 1 coulomb of charge from one position to the other. For that 1 joule of work is done. So that is called the voltage. What is a potential difference? Suppose I have two bodies A and B which are at different potentials. So the difference in potential of the two bodies is called the potential difference. So in this case it is equal to 6 volts. So whenever two points which have different potentials are connected together, current will flow in this circuit. So potential difference causes current flow. And suppose the two bodies are having the same potential. So in that case there will be no current. That is, only when there is a potential difference current will flow, and when both are at same potential there will be no current flow. So EMF or electromotive force is another term which is used instead of voltage or electric potential. So what is this EMF? EMF is a device that helps to maintain the potential difference. It is nothing but a battery. So in this case it is a battery which supplies the current to this circuit. So when current flows here, there will be a drop across this which we can measure it, which is called the potential difference. So EMF is a device that maintains the potential difference. So the points to remember here are, there are two types of charges. Positive charge, it means that there is a deficit of electrons. Negative charge, excess of electrons. And the SI unit of charge is coulomb, and 1 coulomb is equal to 6.28 into 10 power 18 electrons. So next we will see about current. The directed flow of free electrons or charge is called the current, and you need a closed path for the current to flow. And the SI unit of current is amperes. I is equal to Q by T, where I is in ampere, Q in coulombs and T in seconds. If you take the voltage, it is the work required to move the charge through the element from one point to another. And voltage can exist even under open circuit conditions. The SI unit of voltage is volt. V is equal to W by Q, where V will be in volt, W in joules and Q in coulombs. And if you like the video, do subscribe to Read Electric Vehicle channel. And if you want the study material for this one, that is the important hints, you can go through this website. Thank you. These are some of the references.